Imagine trying to balance a pencil on your finger that's the center of mass.
Everyone, in this video, it's a very quick and very crisp explanation of a center of mass. Center of mass is a hypothetical point where whole mass of the body assumed to be centered. So what we are doing, we are assuming whole mass of the body is centered at a single point. So for example, if you see this rod, this mass is distributed everywhere, but we assume that whole mass of this body is centered at single point. So we say its center of mass. If we see this sphere, every point that contain mass, but what we assume whole mass of this body is centered at a single point. This point is called center of mass. Now by same example, again I am repeating same example. Mass of the body distributed over all the volume, but we can assume this whole mass of this sphere is centered at this circle. So we can say center of mass of this sphere is at the center, and this sphere also at the center, and this rod will be also at the center. Now if I join these two by a thin line, now this becomes system. Where is the center of mass of this complete system? Means this one. Where will be center of mass of this? So center of mass of this one will be somewhere here. Now again it's a hypothetical point where we assume that whole mass of the body is centered. Now I will give you another example. Center of mass of this one is at C1. If you see this rod, center of mass of this one is at C1. Midpoint of that. We are assuming that. Now center of mass of this body is at point C2. So separately if you see for body 1, center of mass is at C1. For body 2, center of mass will be at C2. Now what will happen if I combine these two body and take this diagram? In this diagram, center of mass will be between C1 and C2. So if you see what is distance between C1 and C2, that distance will be L by 2. So half of this distance will become L by 4. It means center of mass of these two body will remain at L by 4 from here. That's how we find out center of mass. Theoretical points. Now if I have to find out center of mass of the body and discrete objects, if you have to find out center of mass of the system, in this diagram if we see there is a mass m1 and center of mass of this one, this mass m1 is x1 y1, center of mass of this one x2 y2, this one x3 y3, means position vector of this one is r1, this one is r2, this one is r3. So if I want to find out center of mass, what I'll write, rcm is equal to m1 r1 vector plus m2 r2 plus m3 r3 divided by m1 plus m2 plus m3, and r1 I can write x1 I cap plus y1 j cap. Similarly r2 I can write x2 I cap plus y2 j cap, and r3 is equal to x1 x3 I cap plus y3 j cap. If I substitute this value over here, I can also write xcm is equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Similarly, I can write ycm is equal to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. So this is the formula from where we can calculate center of. Simple example I am taking, very simple example. Let's say mass of this one is m1, mass of this one is m2. So coordinate of this one 0 comma 0, coordinate of this one r comma 0, means length of this rod is r. So length of this rod is r. Now if you have to calculate center of mass, so what I can write here, only xcm I will write, that is m1 x1 plus m2 x2 divided by m1 plus m2. Now axiom I need to calculate. So m1 is, that is m1, but x1 is 0. You can see that is 0. And m2 m2 is, that is m2 only, and x2 is what, r divided by m1 plus m2. It means I can write axiom is equal to m2r divided by m1 plus m2. This you can use as a formula as well. Now let's say we are taking one triangle and mass of this one is 1 kg. Mass of this one I am taking 1 kg, and mass of this one we are taking 2 kg, and mass of this one is 3 kg, and it's a given this is equilateral triangle. This angle will be 60 degree, and side length of this one is 2 meter. So if it is equilateral triangle, so side of this one will be 2 meter. What I am supposed to find out? I have to find out center of mass of the system. Means I need to find out axiom as well as ycium. First I will write value of m1, m2 and m3. It's already given, but once again I am writing, that is 1 kg, that is 2 kg, and this one is 3 kg. Right. Now I need to write x1, x2, x3. x1 is 0, x2 is a, and x3 is uh, x3 I need to calculate. X3 will be equal to, just you see, x3 is equal to 1, x3 will be 1, and a value of a is equal to 2. It means x1 is 0, x2 is 2, and x3 is 1. So using this formula, axiom is equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. I can calculate axiom. So let's see what will be axiom. That will be 1 into 0 plus 2 into 2 plus 3 into 1 divided by total mass. Total mass will be 6 kg. So that will be 7 by 6 axiom. Similarly, we can calculate ycm by same data. I will write just y1, y2 and y3. We already know m1, m2 and m3. So we can calculate. What will be value of y1? That is 0. What will be value of y2? That is 0. What will be value of y3? That we can calculate. See, this is y3 and this value will be 2. This angle is 60. I can write y3 divided by 2 is equal to sine 60. It means y3 will be equal to 1 by 4 into root 3. It means that will be root 3 by 4. Similarly, using that formula, which formula? Ycm is equal to m1 y1 plus m2 y2 plus m3 y3. We can calculate ycm as well. So you can calculate ycm. Now, there is a different question. There are a hexagon, and we are having a 6 particle over here. Mass of this one 2m, this one is m, this one is m, and this one is 2m, and this mass is m. So rather than using 6 thing, we can use this formula. Let's say this is focused on that. Matlab assuming center of mass of these two objects over here. The total mass I will take here 4m, and coordinate of this one is, if this is a, so this one will be a by 2 comma 0. Here if this is a and this one is also a, so this one will become 3a by 2 comma 0, and this one is 2a. It means what I can do, using symmetry, this 2m and 2m I am taking 4m here, and this m and m I am taking 2m here. So this whole diagram is reduced like this. This is 0 comma 0, this one is a by 2 comma 0, this one is 3a by 2 comma 0, and this one is 2a comma 0. And what is the mass of this one? Mass of this one is 1 kg. It's a given. Mass of this one is 4m. Let it be this one also m. This one is 4m, this one will be 2m, and this one will be m. So if I calculate this one, so I need not to calculate YCM here, only I need to calculate XCM. So if I calculate XCM, so XCM will be equal to M1 X1 plus M2 X2 plus M3 X3 plus M4 X4 divided by 4. So if I calculate using that formula, value of M1 is M, X1 0, M2 value is 4m, and that is a by 2, and m3 value 2m, that is 3a by 2, and m4 value, that is m, that is 2a. So if I solve this one, so I'll get from this one 2a plus here 3a plus here a, and of course I divide by m. So after dividing by m, m get cancelled. We divide this equation by m and m get cancelled. So finally what will get answer? Answer will be equal to 6a. Alright. Now let's say find out center of mass of a rod. Here we don't have a distributed system. We don't have a distributed system over here. Here we have a continuous mass system. So for continuous mass system, we have formula xcm is equal to integration xdm, and ycm is equal to integration ydm. So here what I'll do, I'll find out dm. This is the formula. So for xcm, I need to calculate. So xcm is equal to integration xdm divided by integration dm. Just I need to calculate value of dm. dm is what? dm is mass of this small part of this rod. एक छोटे से part का mass है. So for dm, I can write dm is equal to m by l into dx. Just substitute this value. So what I'll get here, x into m by l into dx, and here also m by l into dx. M by l get cancelled, so I will get integration x dm divided by integration dx. This is 0 to l, this is 0 to l. Integration of this one, that will be x square by 2, 0 to l. This one is x 0 to l. If I solve this 2, I will get l by 2 comma 0. We already know if it is a continuous distribution rod, the center of mass should be at the center only. There is no doubt about that. It's very simple. If you have a rod and rod have a uniform distribution of mass, so center of mass will be at L by 2 only. That's what we get from this integration. Right. Now, if I consider a ring, in case of a ring, center of mass I supposed to find out, and this is not a complete ring. This one is a semicircular ring. For semicircular, for complete ring, center of mass will be at the center. We are talking about semicircular ring. So for semicircular ring, here x coordinate, if you see, it's not a variable. Here y coordinate is variable. It means you need to find out ycm is integration ydm divided by integration d. Now I supposed to find out this y coordinate. So this is the y coordinate and this one is r. So what is y divided by r? I will get y divided by r is equal to sine theta. It means y is equal to r sine theta. Alright. What will be dm? dm is equal to m divided by pi r into r d theta. It means dm will be equal to m by pi into d theta. Just we need to substitute these two value and we can find out center of mass of this ring. So ycm is equal to integration y pi की value, that will be r sin theta. In place of dm, what I'll write, m by pi into d theta. And here integration of dm I will write m by pi into d theta. Now if you see this m by pi and m by pi get cancelled, so what I can write here, r sine theta d theta divided by d theta. Now if I integrate this one, so integration of this one will be from 0 to pi, and here also 0 to pi. If you see that integration will be from 0 to pi, because theta minimum value can be 0 and maximum value can be pi. It means integration will be from 0 to pi. So what I write, this is r, and integration of sine theta is minus cos theta 0 to pi divided by, here I will get pi. So if I solve this one, I will get finally 2r divided by pi comma 0. That is xcm comma ycm. That's how we find out center of mass of a circular ring. When we are finding out center of mass, in that case what we are doing, we are putting mass on that one. It means whatever mass we are putting, we have to add it. But whenever we are removing mass, then we have to subtract it. Now in this question, we are cutting the ring from this one, means this ring we are cutting from bigger ring. So where will be center of mass? What is the question? Center of mass of this ring will be at the center. If I am not removing this ring, if I remove this ring, where will be the center of mass? So first thing, if I remove this ring, how much mass I supposed to remove? So for that, if area is pi r square, for bigger ring radius is r, if area is pi r square, how much mass is there? M. If area is 1, mass will be m divided by pi r square. If area is pi r by 2 chi square, so that mass will be m divided by pi r square into pi r square by 4, that will be m by 4. It means whatever mass I remove from this one, that is r m by 4, because we are removing this mass is what? M by 4. Now m1 is m, but m2 is minus m by 4. Why minus? Because we are removing this mass from here. X1 is 0, is this coordinate I am writing 0 comma 0, and this coordinate will be r by 2 comma 0. So this coordinate will be 0 comma 0, and this one will be r by 2 comma 0, and this one is 0 comma 0. So x1 is 0 and x2 is r by 2. So now I have to use this formula, xm is equal to m1 x1 plus m2 x2 divided by m1 plus m2. I substitute value, m1 is m, x1 0 minus m by 4 r by 2 divided by m minus m by 4. If you solve this one, you will get minus r by 6 comma 0. It means what, say xcm and ycm, minus r by 6 comma 0. So when we are removing mass, simply just we have to put that mass minus, we are able to calculate it. Now if I remove mass from both sides of the ring, so if I am removing mass from both sides, from here also, and I am same mass I am removing from here, you can see by symmetry xcm will be at same point only, because if we are removing right side, it will be shifted left r by 6, but if we are removing left side mass, it will be shifted right side a distance r by 6. So finally it will shift at this position, so center of mass will remain square, and length of this square is given 2l. Length of this square is 2l. Now I have to remove a ring of radius l by 2 from here, and where will be center of mass I supposed to find out. So first thing, I need to find out how much mass I removed. So if you see, area of this square is 4l square, mass is m. If area will be 1, mass will be m divided by 4l square. If area is pi l square by 4, what will be mass? m divided by 4l square into pi l square by 4, that will be pi l divided by pi l square division l square, sorry, get cancelled. So what I'll get finally, pi m divided by 16, pi m divided by 16. So this much mass we are removing. Now if I ask you what is x1, x1 is 0, this coordinate. What is x2? X2 will be l by 2. So what is xcm? Xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Now you have to substitute this value, but m2 has to be negative. m1 की value how much? m1 is m, and m2 is that is minus pi m divided by 16. So if I substitute this value, that is m, x1 value 0, m2 pi m divided by 16, and x2 is r by 2 divided by m minus pi m divided by 16. So if we calculate, you will get value of xm is pi l divided by 2 into 16 minus pi, and ycm minus pi l divided by 2 into 16 minus pi. By same method you have to calculate xcm and ycm.